this assessment, we're given a C13 NMR spectrum and a molecule and asked to assign each signal to the carbons in the molecule shown. Let's work right to left. So if we start with carbon A, we look at the chemical environment of it. It's a carbon attached directly to an electronegative atom. It's an sp3 hybridized carbon. And so that being sp3 hybridized and attached directly to an electronegative atom like chlorine or oxygen or nitrogen is going to put it in the range of 50 to 100 or around there. So we know it's either going to be one of these two. This one here is closest to 50, so that's probably going to be carbon A. Let's move over to carbon B, which is an alkene. Carbon B is an alkene, so we expect it to show up between 100 and 150. Carbon C is also an alkene, and so we would expect it to show up between 100 and 150 as well. So we know that these two peaks are both going to be the alkenes. Now we have to make a guess about which one is A or which one is B, which one is C. The fact that B is closer to the chlorine and the chlorine is electronegative, we expect the carbon at B to maybe feel a little bit of the induction of the chlorine, and so we'll predict that this is carbon B, which would mean this one is carbon C. That leaves us only to assign D and only one signal. Let's do that by looking at what is D. It's an sp3 hybridized carbon. It's not directly attached to an electronegative atom, but it is next door to a double bond. We expect that to be between 0 and 50, really far away from that 50 range. And so this signal here is probably D. Probably, highly likely is D. If you're looking at speaking of probably and highly likely, what are we most sure of? We're most sure of A and D. B and C, if you thought those should be flipped, that's not a huge problem. To be honest, I'm not sure which one it is, but that works for me. If you flipped them, that would work also. The key here is they're between 100 and 150, which is where sp2 hybridized carbons show up in the C13 NMR.